Hypothesis test for the population proportion. A hypothesis is a conjecture, or a statement, or a claim, or an assertion about a population. Now, in terms of statistics, it will usually be a statement about the value of a parameter, such as the population mean mu or the population proportion p. A test of hypothesis is just a statistical procedure used to make a decision about the conjectured value of a parameter. It involves making a decision between two hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis, denoted as h sub 0, specifies a value of a parameter. This hypothesis is assumed to be true, and an experiment is conducted to determine if the collected data is contradictory to the null hypothesis. We will write this statement as h sub 0 parameter equals a hypothesized or assumed correct value. For example, we might write h sub 0 is that p equals 0.25. The alternative hypothesis, which we write as h sub a, usually we will write it as h with a lowercase a as a subscript, but other resources might have a capital A as a subscript, or instead of using the a, they may write a 1 as the subscript. This just gives an opposing statement about the value of the parameter. The collected data will be analyzed to see if it supports this alternative hypothesis by casting doubt that the null hypothesis h sub 0 can be correct. Specifically, we assume that h sub 0 is true and determine how likely or unlikely the sample data would be. If the sample data would be unusual to observed, and yet we just observed it, then we reject the idea that h sub 0 is correct. A test statistic is a quantity calculated from the sampled value of your data or statistic, which is then used to calculate a probability or a p-value for a test of hypothesis. The z-score will be used as the test statistic for a proportion. Now, the probability or p-value of a test of hypothesis is the probability of obtaining the observed value of your sample statistic, or one which is even more supportive of the alternative hypothesis, under the assumption or believing that the null hypothesis really is true. In other words, if the null hypothesis is true, how likely is it that we would get this particular sample data, or something which is even more contradictory of the null hypothesis? A decision rule just allows us to make a decision between whether we believe the null hypothesis or not. If the p-value or the probability we calculate is large, this implies the sample data is typical or common or not unusual, and we decide that we will fail to reject the null hypothesis. The null hypothesis might be true. On the other hand, if the p-value is small, this implies the sample data is unusual based on the value used for the parameter, and we decide that we will reject the null hypothesis. It is likely not true. h sub a, the alternative hypothesis, is more plausible. The decision rule just tells us when we say the probability or the p-value is small enough to believe that HA is true. The value we compare against is called the significance level or the alpha level in a hypothesis test. We discuss it in more detail later, but for now it will just be a value such as 0.01, 0.05, or 0.10. It may also be given as a percentage such as 1%, 5%, or 10% for the significance level. the rule will then just state reject H sub 0 if the p-value or probability is less than or equal to your level of significance. For this class, you also need to write a statement which summarizes your findings. It will involve an interpretation of your findings. It should give information including the level of significance you used to make the decision, what the parameter is or what it represents in the scenario, and if you support the statement for the alternative hypothesis. The format typically would look something similar to this. At the 0.01 or whatever level of significance, there is or is not significant evidence to conclude the proportion or percentage being examined in the scenario is, and then you're going to be comparing it. It's greater than, or maybe it's different than, or maybe it's less than the value given in the null hypothesis. But you would actually enter the actual value. If you're asked to verify that the hypothesis test is valid, you're going to refer back to the conditions which allowed the treatment of the sampling distribution of the sample proportion to be well approximated by a normal curve. In this case, you're looking for a random or representative sample, and it would be categorical data. N times P should be 10 or more, and N times Q, or N times 1 minus P, would also need to be 10 or more. So these were the conditions under the sampling distribution when we can make z-scores and find probabilities.